Good evening, everybody. Welcome to Wednesday Night Rabbit Hole. We're live over there on Rumble, and we're live here on Twitch, and we're live there on YouTube, and we're live on the world, baby. and um, what happened there?
5.5. Yeah, 16 kilometers.
Macquarie Island, 5.5.
Oh, the Macquarie Islands below Australia, right?
Yeah.
Yeah. Well, there you have it.
We had the emergency alert now. Macquarie Island.
Yeah, New Brunswick, Canada had the news alert say some internet outages, and his whole TV was going off and his phone was going off. All these emergencies, like, dude, it's just an outage. My land, and then we were joking about earthquake happening during the show, and bam! As soon as they pushed go, an earthquake happens. Oh, Canuck had to eat that darn candy bars, didn't he?
Yeah, I had them like an hour ago. It's been downhill ever since.
Yeah, no kidding.
After making magic happen.
Yeah, I ate my coffee. It was so thick. Yeah, yeah, boy, woo. Feeling lightheaded there, buddy. Good evening, everybody. Tonight's story is Northern Oregon. However you want to say it. I say it different ways, but we're going to talk about some structures fault-wise in Northern Oregon, and the implications that there are serious possibilities for multiple sevens in Oregon. I'm not talking about off the coast either. Unrelated to the coast. Well, indirectly related, but not caused by the Cascadia.
Not caused by Cascade.
Not part of the Cascade. This is new information coming out over the last few years, and we're going to talk a little bit about that. And we're going to talk a little bit about history. There's not many large earthquakes in Oregon that have happened, but there are some key ones that, as we normally do, by looking through the historical record and watching the patterns that persist, Oregon is kind of like it's a stepchild. Nobody ever pointed out that, hey, it was happening there when it was happening everywhere else too. And so we're going to talk a little bit about that. So without further ado, let me get do we have any links you want to start with there?
Yeah, I'm going to do the big one first. It's a study from 2021 because it explains, like, we're focusing on the Portland area, but it's going to explain how it connects to everything else.
It is quite complicated. The Willamette Valley and the edge of where Silesia has come across. We were talking earlier about what's happened off here. Very, very strange. Some of the Columbia basalts in the Columbia River and the Silesia basalts and the lack thereof, and why things are the way they are, and the northwest southwest trending structures and the spin of Oregon. Yeah, the clockwise spin of Oregon.
Yeah, you'll see that they have a bunch of maps in this study that explains all that. It even shows the rotation and shows where the faults are in relation to it and all sorts of crazy stuff.
Yep. This article is found on Geosphere. It's the spatial temporal evolution of Portland and the Tualatin Fork Basins, Oregon, USA. And the author would be Darby Scanlon, John Bershaw, Ray Wells, and Ashley.
Well, we know Ray Wells' name from Nick's stuff, right?
Yeah. And I want to say John Bershaw is been a voice that came out too. And I think Darby even.
Yeah. John Shaw's the Canadian one.
Yeah. Yeah. Cool, Pat. So
because what this one does explains how BC is connected to Portland. That's what
Right. Right. This is going to be great. So I'm going to download slide.
Now, I'm not going to read the whole thing. I'm just going to do the abstract, the introduction, and the because it explains in this like how they found all this stuff out. They did 166 drill points that they went down in to find everything that was underneath the basin through the Columbia River and everything. It's freaking crazy.
All right. So this is the map we're looking at. Here's the Columbia River that comes out here. And try to get you the ocean is to the left, of course. We're not on the ocean. We're interior of the ocean. And Portland is way inland, actually. It's like in the middle of the state. I've been there. Fished the river. Loved it. I'm not so big a fan of Portland, though. There's a lot of strange
it's like
goings
any
on.
other big city.
Strange goings on. That's all I got to say. Just strange goings on. So, go ahead, Canuck. You can.
Okay, so I'm just going to read the first
The
two
abstract.
parts. The abstract, the introduction, the geological setting, because it explains all the quakes, the faults, everything, how it's all connected. So it's pretty good.
Mm-hmm.
So when I found it, I was very happy because it was like setting up everything perfectly. So it's good. I'm going to bring it up here on my screen. So the title of it, The Spatial and Temporal Evolution of the Portland and Tualatin, or Tualatin, however they say it, Fork Basins in Oregon, USA. The Portland and Tualatin Basins are part of the Salish, which is the Salish Sea up by Vancouver, Puget Sound, Willamette Lowland, a 900-kilometer long forearc depression lying between the volcanic arc and the coast ranges of the Cascadia convergent margin. Such inland seaways are characteristic of warm young slab subduction. We analyze the basins to better understand their evolution and relation to the Coast Range history and to provide an improved tectonic framework for the Portland metropolitan area. We model three key horizons in the basement. 1, the top of the Columbia River basalt group. 2, the bottom of the CRBG. And 3, the top of Eocene basement. So what they're doing, just to simplify this in this study, is finding out all the stuff that's underneath the Portland area, the same stuff that's Nick's been talking about.
Basement rocks. It's talking about all the basement stuff, everybody.
Yeah. So it says isochore maps constrain basin depicenters during Pleistocene to mid-Miocene time, so 0 to 15 million years ago. CRBG 15.5 to 16.5, so the same numbers that was in the last episode and what Nick and them have been talking about. And early Miocene to late Eocene, so 17 to 35 million years ago. The results show that Portland and Tualatin basins have distinct mid-Miocene and quaternary depicenters, but were one continuous basin from the Eocene until mid-Miocene time.
Which backs up the course we take with Professor Nick. And what was that gentleman's name? He's great. And so the supposition is that from Oregon all the way north to Canada was basically lowland, swampy kind of stuff before the Cascades and before Silesia came in. Yeah. And this is the effect.
And then this is how it's getting into the faults and all that. A northwest striking gravity low, coincident with the northwest striking fault bounded Portland Hills anticline, which to explain this further, the Portland Hills is the main fault that goes through the center of Portland.
Yeah, right up in here.
Portland Hills anticline is interpreted as an older graben coincident with observed thickening of the CRBG flows and underlying the sedimentary rocks. So basically this fault, the Portland Hills one, was there way before.
Right. And
all this other
again,
stuff.
just like what Professor Nick was talking about, the Seattle fault. It was
Yeah.
there prior to the Cascades, prior to Silesia.
So then it says neogene transpression in the forearc structurally inverted the Sylvan Oatfield and Portland Hills normal faults as high angle dextral reverse faults, separating the Portland and Tualatin basins.
It's
An
a spreading
eastward,
center, yeah.
an eastward shift of the forearc basin epicenter and tenfold decrease in accommodation space provided temporal constraints on the emergence of the Coast Range to the west, because see, the Coast Range wasn't there until after all the stuff smashed in.
Mm-hmm.
Clockwise rotation and northward transport of the forearc is deforming the basins and producing local earthquakes beneath the metropolitan area. So they're saying all this to say why it has faults there that are going to make big quakes.
Right. So in the down through the middle of the Portland fault zone, it's a spreading and it's an anticline, so it's a drop, and it pulls apart as it drops down.
Yeah. And
So
now
it's
the next section is fun here. I liked it because it compares it to other places in the world, and it's all one we talked about before. So I like that they did it that way. The Portland and Tualatin basins are part of the Salish Puget Willamette lowland, a forearc trough along the Cascadia subduction zone that is formed by oblique convergence.
It's an uplift, sorry.
Yeah, of the Juan de Fuca plate beneath North America. The inland Salish Puget Willamette lowland, that's quite the tongue twister, trough is separated from offshore basins by the Coast Range, and in that respect, it is similar to the Nankai margin of southwest Japan, southern Alaska, and southern Chile. Now, this is going to be important for later.
All right.
Such inland.
So a structural geology anticline is a type of fold that arc-like shape that has its oldest beds at its core, whereas a syncline is the inverse of an anticline. So I misspoke. I just want to say, it's an uplift and a spreading out of, and that's where you see the beds, the deep beds you can see. So that's what's going on. So on that Portland faults, I wanted to correct that. Go ahead.
Yeah. Now the next one here, the next part of this paragraph is going to give examples of quakes in these type of areas that we know about. Such inland seas and lowlands are population centers, because everybody moves there, because that's where they want to live and build cities. And they are tectonically active, producing, for example, the upper plate 1995 magnitude 6.9 Kobe earthquake in southwest Japan, and Cascadia's magnitude 7 plus Seattle earthquake circa 900 AD, which we've talked about before. And we'll end up doing more because now they think it actually happened in 923. So the new stuff is more closer, or even more better. And in the lower plate, Cascadia's 2001 magnitude 6.8 Nisqually earthquake, which we haven't talked about yet, but we will when we get to Washington. And the 2019 magnitude 7 Anchorage earthquake, because Anchorage is similar setup as how this is. So that's pretty interesting too. Rogers in 2002 suggested that these margins with inland seas were the product of young warm slab subduction, and more recently, Bodmer and a bunch of other people in 2019 have correlated Cascadia's Coast Range elevation with buoyant asthenosphere along strike, which is the same stuff that Nick's been talking about with the stuff up where they are in the Olympic Peninsula, talking about stuff. The Coast Range appears to be primarily a late Neogene feature, as flood basalts of the Columbia River basalt group sourced from the back arc flowed across the forearc into the ocean across the broad front from the central Oregon coast to the central Washington coast between 16 and 12 million years ago. The uplift of the Coast Range may be superimposed on or partly coincident with the Neogene forearc transition from Paleogene transtension, well, there's transtension again, and mafic magmatism to deformation dominated by north-south transpression. Well, there's the north-south stuff again, due to impingement of the northward migrating forearc against the Canadian coast mountains. So the Canadian coast.
See, so the Canadian rocks, the Canadian or that's not the forearc, but it's the Canadian Rockies. They're stopping the movement northeast of Oregon, and so it's bending the topography like a big bow, so to speak. Am I correct?
Yeah. So now this next section, the record of Oregon Coast Range development, forearc migration, and cascade magmatism, as recorded in the stratigraphy of the Portland and Tualatin basins, is poorly understood. In this study, we provide constraints on the structural and tectonic evolution of the Cascadia forearc by tracking basin depocenters, areas of maximum sediment accumulation in the Portland Tualatin basins through space and time. Previous geological and geophysical studies have been conducted in the Tualatin Basin and in part of the Portland Basin. Through an integrated geologic model, both the Portland and Tualatin Basins, though an integrated, I missed the word integrated, geological model of both the Portland and Tualatin Basins currently does not exist. We've synthesized log outcrop, seismic, aeromagnetic, and gravity data to better understand stratigraphic architecture and spatial temporal evolution of accommodation space within the Portland and Tualatin forearc basins. We then use these observations to provide temporal constraints on the emergence of the Oregon Coast Range and initiation of transpressional deformation within the Portland metropolitan area. Our basin model also provides information needed for ongoing seismic hazard and resource assessments in the Portland metropolitan and surrounding areas. So the reason why I'm interested in this, because it's getting to the faults and quakes. So that's like the whole, I'm not going to do this whole thing, but I'm going to
just do it. Just do it. What you got to do.
I'm just going to read down to the end of the geological setting because that explains everything that we're going to be looking at tonight. So now the geological setting part. The Portland and Tualatin basins cover an area of 3,900 square kilometers and are part of the 900-kilometer long Salish-Puget-Willamette lowland, a forearc trough situated between the Coast Range and the Cascade volcanic arc. The basins are elongated in a northwest to southeast orientation and are generally bound by northwest striking dextral strike-slip faults. So a dextral.
They're saying these are what kind of basins? What was it?
Well, it was all one big basin all at one time.
Right. But what I'm saying is it's a basin by the time 50 million years comes in. And it was a flatland, lowland, and they don't have evidence of the old subduction zone. I wonder if this basin is part of that.
Well, it would have been before, right? Because all those islands that were coming in.
Right. You know what I'm getting at, right?
Yeah, it explains it a little bit down here.
Okay, cool. Go ahead.
Yeah.
Sorry.
Okay, the base, because it talks about what it looked like before. The basins are elongated in a northwest-southeast orientation, are generally bound by northwest striking dextral slip faults. A dextral sense of motion on these bounding faults is compatible with modern stress field, where the maximum horizontal compressive stress is oriented roughly north-south. essentially 45 degrees oblique to the northwest, striking faults. In Paleogene time, the Tualatin and Portland basins were part of a large continuous marine basin that stretched from the Portland Basin west to the present day ocean. So see, it's saying there was a
It is a
massive-
basin, yeah. I mean, it was underwater.
Yeah.
So it makes sense. And then all the stuff that's out here, when Silesia came aboard, the coastal ranges are all uplifts, and that's the one article I read to you earlier that talked about.
Yeah, so it ties into this one.
Mhm.
It's like what you were talking about, even though it was Gales Creek Fault, but we'll talk more about that after.
Sure. Go ahead, bud.
Yeah. So 2 crustal earthquakes of greater than magnitude 5 have been recorded in or near the Portland and Tualatin basins in the past 60 years. A magnitude 5.2 earthquake occurred in the Portland Basin in 1962, and the March 25th, 1993, magnitude 5.7 Scott Mills earthquake that occurred 58 kilometers south of Portland indicates that damaging earthquakes are possible. The Gales Creek Fault west of the study area shows evidence for quaternary activity. And that's from like 2019, 2020.
Mm-hmm.
Bunch of different studies. As clockwise rotation and northward migration of the Oregon Coast Range results in a dextral shear on faults in the study area and across the forearc. The stratigraphy of the Portland and Tualatin basins records a history of volcanism and sedimentation in both fluvial and marine depositional environments.
Fluvial means it's kind of a fan that goes out. Am I correct? Or am I wrong?
Yeah, it sounds like Aaron Donahue could have wrote this one. It's all the same words. Oceanic basalts and basaltic sedimentary rocks of the Siletz River volcanics, commonly referred to as Siletzia, comprise the Eocene basement underlying Cenozoic basin fill of the Portland and Tualatin basins. Accretion of the Siletzia terrain to North America at the latitude of Oregon occurred between 51 and 49 million years ago. So all the same stuff Nick's been talking about.
Mm-hmm.
West of the study area along the east flank of the Coast Range anticline, basement rocks exposed are lower Eocene submarine basalt of the Siletz River volcanics. Now, I need to explain this. So that's
Go
what they
ahead.
used to call it because they found the rocks at the Siletz River. So that's where the Siletzia thing came from. But it was originally called the Siletz River volcanics. Associated diabase hills and subaerial basalt of the mid-Eocene Tillamook volcanics. The southern part of the Portland Hills anticline separating the Portland and Tualatin basins is underlain by the Eocene basalt of Waverly Heights, best exposed adjacent to the Willamette River near the Waverly Heights area. Waverly Heights basalts are similar to Tillamook volcanics and are evidence of Eocene Siletzia basement below. Cascade Arc volcanism was near its present location by 45 to 40 million years ago after the accretion of Siletzia and westward migration of the subduction zone.
Yeah, see, when let's kind of explain. I don't know if they can see that. Let me see. They cannot see this, so I have to make a way for them to see it. Yeah, hold on. I'm going to draw again. I love to draw. You know that. Yeah. Window. Here we go. All right, loading. There we go.
Nick would probably be all excited if you read this one because it's talking about.
I know, right? He may have written it. There's a fork, or not a fork, but the trench. When a piece of land goes over that trench, what we've seen is the trench migrates at the direction of if the land is moving that way, the trench actually moves with it, so the trench can do this. And it might be, now that I said that, I wonder if there's any proof to it. But in looking at USGS here real quick, there's the big boomer down there, 5.7 Mockery. Also, it looks like Philippines got a 4.6, and so did Nepal. So power moving out of away from that 7 has gone pretty far, and it appears it's going toward India. But reason I stopped you to said is right here. There's an interesting thing about the South American Peru-Chile trench. Between Chile and Peru and Ecuador, there's a good part of Peru that does not have any volcanoes.
Yeah.
And it might be that this trench is on its movement away because of the what do you call it, North or South America moving over it. And because it's shallow, it doesn't have time to produce any volcanics. And we learned that in the class too. So that's pretty interesting what you're saying there. That although when the Cascades happened, that's a whole different event. But
yeah, and that's what it talks about here next.
Yeah, go ahead, bud.
Next sentence. A bunch of people with Wells, Humphreys.
Mm-hmm.
We've heard both Wells and Humphreys names with Nick stuff. Suggested that the Western Cascades erupted over a well-developed sedimentary basin,
Mm-hmm.
and that the eastern boundary of Silesia exists beneath the Western Cascades, which is the same stuff that Nick's been talking about.
Right.
Okay.
And they saw on Nick's stuff, they saw that there's a clear delineation between that. So they're still up in the air. They don't know there's any proof that Silesia is under the Cascades right now. But if it is, it's way down there, because down at 25 kilometers, it's not there in Washington. Now, Washington's border is just north of what we're talking about now.
And Aaron said that Silesia is way thicker in Oregon than it is in Washington. So it's thinner up in Washington.
She said it's really thick up there in Oregon, huh? That's pretty interesting right there. So it's pushing up the coastal ranges.
She said it was, I think, 8 kilometers thicker above Washington, Vancouver, and then she said 20 to 30, I think, in Oregon. The thickness.
Oh, really? Well, in the article I read, it said that Silesia is actually vertical now.
I think that's what she was getting to, because it was way thicker. So probably somehow flipped it or did something.
Yeah.
Well, she said it could have been because there was more basalts at the bottom, closer to the hot spot too.
Right.
So
and what we've learned is
she asked her.
Right. What we learned with basalt,
yeah,
in a subduction zone, basalt is lighter than the other stuff, and it gets burned out and it gets brought to the surface, versus the thicker stuff, and that's what creates the subduction zone, subducting plate to go underneath. So over time, the heat and gases and cracks up the basalt, and it rises to the surface. So whatever's a basaltic oriented, it has to come up. That was pretty interesting from class 2.
Yeah. So now the next line, paleoaltimetry, whatever on earth that is, results from
paleo.
Support interpretations that the Oregon Cascades were high by Oligocene time. Following the accretion of Silesia to Oregon, at least 2 kilometers of marine and marginal marine sedimentary rocks were deposited in both the Portland and Tualatin basins from Eocene to Oligocene time. All these crazy words.
Yeah, you know what?
years ago.
Yeah, they put it in, the eras, the dates. Yeah.
In the Portland Basin, deposition of these sediments was coeval with eruptions from an incipient western Cascade volcanic arc, and their eastern extent delineates the Paleogene coast. In mid-Miocene time, the Columbia River basalt groups erupted 210,000 cubic kilometers of flood basalt from a series of dike swarms near the present-day junction between Oregon, Washington, and Idaho.
Okay, east, yeah.
Yeah, at 15.5 to 16.5 million years ago. Flows of the Grand Ronde basalt passed through the Cascade Range via the ancestral Columbia River into the nascent Portland and Tualatin basins. CRBG unconformably overlies volcanic rocks of the older eroded Paleogene and Neogene Western Cascades, and so the ghost volcanoes, and uplifted marine sedimentary rocks as flows inundated the Portland and Tualatin basins. Late Miocene volcaniclastics, that's quite the word, of the rhododendron formation overlie the CRBG in the southeast portion of the Portland Basin on the west flank of the Cascade Range. The lower Sandy River mudstone was deposited in the basin during the last half of the Miocene. This unit is interpreted as lacustrine, whatever that is, consisting of silt and very fine sand.
Mm-hmm.
At the end of the Miocene, the Columbia River began to deposit coarse sandstone and conglomerates of the lower Troutdale Formation. So I'm remembering all these different formations.
Yeah, I hear you.
Other stuff. Class composition suggests an extra basinal source in pre-Cenozoic rocks in eastern Washington and Idaho. The upper Sandy River mudstone was also deposited during this time, suggesting the ancestral Columbia River was a meandering system with low energy floodplains. Low potassium tholite flows erupted at 3.5 million years ago in the Cascade Range to the east. Wasn't Goat Rocks 3.5?
Yeah, I mean it's Goat Rocks.
That's interesting. I thought one of those ones that he was on.
I thought Goat Rocks was. Were they the older ones?
Yeah, one of the older ones. One of the first one he did there with when they first started. I'm pretty sure
Goat Rocks burned through. Yeah, Goat Rocks burned through the it's younger. It burned through the
So they're saying that
basalt.
stuff was happening down here at 3.5 too. So that's interesting.
Well, it stands to reason that happens too. Again, they're only 1,000 miles apart or less. Yeah. They're probably about 500 miles apart.
Yeah,
it's interesting there.
So this resulted in deposition of hyaloclastic sandstone, member of the Troutdale Formation. Well, this is getting crazy here now. And it's talking about, alluvial fan in the eastern portion of the Portland Basin. Conformably overlying the CRBG in the Tualatin Basin are 450 meters of late Miocene and younger fluvial siltstone, sandstone, mudstone, and the Hillsborough Formation. So there's a whole crap load of sediment on top of all this stuff. On the basis of gross lithology and stratigraphic position, consider these sediments equivalent to the Sandy River mudstone. However, Wilson in 2000 suggests that the Portland and Tualatin basins have been relatively isolated from each other since late Miocene time based on differences in elemental geochemistry, plots of silt and clay samples from whatever. The present day topography of Portland and Tualatin basins is influenced by underlying structure and geologic events of the past 2.5
million years. Yeah.
Million years. Faults trend northwest to southeast throughout the study area, influencing stream erosion and the distribution of high topography. The boring volcanic field, which we've I think talked about before or mentioned or saw it in one other things.
Yeah.
Consisting of cinder cones and associated lava flows, small shields and lava cones erupted west of the Cascade Arc axis during the latest Pliocene. More recently, late Pleistocene glacial outburst floods, the Missoula floods, inundated and scoured the study area, depositing mud, sand, and gravel on the valley floors. The modern boundaries of the Portland and Tualatin basins were established by mid-Miocene time based on distribution maps of the CRBG and the version of gravity data. Cross sections based on a gravity survey through a light rail tunnel in the Portland Hills show step-like anomalies that are consistent with steeply dipping reverse faults, bounding the Portland Hills anticline, a structure consisting of CRBG that separates the Portland and Tualatin basins. The Sylvan, Oakfield, and Portland Hills faults comprise part of the larger northwest-oriented Portland Hills Clackamas River
Been there.
zone described by Beeson way back in the 80s and Blakely in the 90s. This zone has experienced folding and faulting since mid-Miocene time. South of the Beaverton Fault, Cooper Mountain and related subsurface structures are interpreted as east-west oriented anticlinal folds in CRBC. From the hanging wall of the Beaverton Fault, these folds reflect the northward motion of Western Oregon in Neogene time. So they're saying there's east-west ones too, which are just like Seattle Fault and Tacoma Fault and all that. So
Yeah,
there's
Neogene contains 23,000 all the way to 2,500. So
and that's all I'm reading in here because it explains where they drill all the holes.
right.
All that we'd be here to.
So we'll be here till whenever. So to summarize what you've been reading, which is a lot of words, how do we digest that? So the stratigraphy of Portland and the Tualatin basins records a history of volcanism and sedimentation in both fluvial and marine depositional environments. So fluvial is like a fluvial fan, like what comes out of a river. And marine depositional environments, that means stuff that eroded off of mountains, off the shore, and out to sea.
Well, I could summarize this whole thing in about 2 sentences.
Do it.
Back long ago, this was a gigantic basin that went all the way from Vancouver to Portland. And it has a bunch of northwest to southeast faults in it.
Yeah, well, we know that much.
They can make sevens. So get excited.
Yeah, and they didn't talk about those, but it has a lot to digest. The Silesia stuff, the Siletz River volcanics, commonly referred as Silesia, comprised of the Eocene basement underlying Cenozoic basin full of Portland and Tualatin basins. I don't think Silesia is where Portland is. I think it's west, way west of it.
It's not over that far.
Right. And
it would probably be to where the edge of the Gales Creek Fault is, I would say.
Yeah, and that would be right here on screen.
Which is edge of the coastal range.
So the purple is the Siletz terrain, okay? And then there's the in the middle here is what's left of the rocks and the fluvial stuff and sedimentary stuff that all just went down the rivers.
I think the Siletz River is actually in the coastal range, if I remember when I looked it up.
And the Willamette, yeah, it's all in the coastal ranges. And the Willamette River turns into the Clackamas and then hits into the Columbia River. Interesting that the basalt group is the chocolate cake. You see it, all the brown. That's the Columbia River basalts, and but there's no volcanics in that. other than the boring, which is the orange color you see on screen. And I'll make sure you all can see that because I'm not looking at. Yeah, you can barely. I can zoom in on it so you'll see it there. All right.
Okay.
And
now
and
the next article I want to do is super new.
right. And the cascades are all out here, this kind of peachy color. So what you have is cascades, the boring volcanics in the middle. Then you have sedimentary and fluvial plain stuff, superficial deposits, marine basin stuff, and then the Columbia River basalts that ended up in the middle, and then you have out here, you have Silesia. So there's kind of really lines of demarcation through this whole area, but they're still in a basin. And parts of it have anticlines. Now, if you ever been down the Columbia like I have, there's a lot of hills and a lot of that Columbia River, where the Columbia River goes. It's deep. It's like a canyon that goes through there, and it's just fantastically beautiful too. But anyway, so you got another article you want to talk about?
Yeah, it's a Tumblr one from 2023. So it talks about it goes into the simpler version of this about all the faults under Portland. So,
all right,
do next. So it's pretty straightforward. It's not all complicated worded salad like the other.
Good, and yeah,
Goldfinger's in this one too. So,
oh yeah, Goldfinger. Is he a proctologist?
oh wow, he's the turbidite man.
He's looking for a turd.
Yeah,
He's a turbidite. Yeah. All right. Citation is Portland seismic hazard stems from subduction zone local faults. This is Alice Turner. What's the date in this one here? July 20th, 23.
Yeah.
Portland seismic hazards stem from a subduction zone and local faults. The big one, the Cascadia subduction zone, is a 600-mile long, 1,000-kilometer plate boundary where the oceanic Juan de Fuca plate dives beneath North America's continent. This subduction zone has been relatively quiet and unassuming for the past 3 centuries, with little recorded seismicity. But in the 1980s, scientists realized that the quiescence may be foreboding, that this quiescence might be. Science has found multiple lines of evidence confirming that the Cascadia subduction zone could host the most destructive type of earthquake, the so-called megathrust. Seismologists have carefully analyzed marine and land sediments, finding evidence of between 19 and 20 magnitude 9 earthquakes in the last 10,000 years. Right now, we're possibly at the tail end of a cluster of 5 events that started 1,500 years ago. And they're about 350 years apart, says Cascadia expert Chris Goldfinger, an earthquake geologist at the Oregon State University. And the last one we had was 1,700. Add 350, that'd be 2050, right? Yeah. The close one, although a possible Cascadia megathrust earthquake has been the headliner when it comes to the coastal Oregon seismic hazard, it is not the only fault in the region, and that could be destructive. Many active faults are scattered around and beneath Portland. These faults also result from plate boundary. They result from the plate boundary. The Juan de Fuca is not colliding with North America continent head on. Instead, its motion results a clockwise rotation as it subducts, which is mostly accommodated with the overriding North American plate by local shallow crustal faults. For instance, Gales Creek Fault hosted earthquakes roughly 1,000 years ago and 4,000 years ago and about 8,000 years ago. So, says Ashley Strigg, a professor at Portland State University and a co-author of a recent study. And I know I'm going to find that recent study about the local structure of from 45 miles long surface expression of the fault. The research team estimated that the fault could produce a magnitude 7.2. This active fault lies mere 22 miles west of Portland. Whoa.
Yeah,
Other faults,
the newest stuff now says 7.4.
yeah. Other faults like those within Portland are less well studied. The Portland Hills Fault, for example, runs through downtown Portland, but its especially hazardous location underneath the city cuts it off from the scientists keen to study it, resulting in a lack of information about the past earthquakes. However, because this and other urban faults have the same northwest orientation as well-studied faults outside the city, scientists can infer that the stresses from plate motion are distributed among them. As a result, says Strigg, other structures near Portland metro area are also likely to be a seismic hazard. Different faults, different feel. Both how earthquake feels to people and the damage that it causes depends on the distance from the fault that ruptured. When we talk about seismic hazard in the Pacific Northwest, particularly Oregon, I noticed that the focus is the big one, says Strigg. The crustal faults have less frequent, smaller magnitude earthquakes than that of the subduction zone. And so they have a lower hazard, but they are close by and they shouldn't be ignored, she says. If the earthquake ruptures near or even directly beneath the city, the ground shaken, even of a moderate magnitude, could be a short but intense with little warning. This means little or zero time to be in a protective action. That means bing, no warning. You won't have time to react, says Goldfinger. Usually the time you figure that you're having an earthquake, it's all over. Megathrust earthquake scenario presents a different risk. Shaking would be 5 to 7 minutes. However, such rupture would likely be near the coast, more than 50 miles from Portland. These 50 miles would act as a buffer because the amplitude of seismic energy would decrease as a seismic wave traveled inland. A megathrust earthquake for Portland would be little more gentle, let's say, than a local event. The seismic energy from an earthquake would be detected via seismometers close to the fault well before it reaches Portland, which means the city dwellers would have up to a minute of warning to take protective action before the shaking starts. Yeah, it depends on how big it is, right? Yeah. Whether or not earthquakes is the big one or the close one, more than 2 million people live in the metropolitan part of Portland, many of whom would be at risk in either scenario. So the estimated be 18,000 fatalities in Oregon if the big one hit. Mm-hmm. $70 billion in excess of damage. And it goes on to a whole lot more. So, yeah, we don't need to focus on all those.
About
the damage to the cities itself. Wow. So, in preparing for earthquakes, what seismologists do is they get all the information, bring it together, and then present it to the city planners, and the city planners argue about it, and then it goes in the can. And until something happens, and they go, "Oh, who threw it away? You did. Yeah. So that's kind of what happens. What else you got for me, bud?
Now the next one talks about the historical quakes around Portland. Right. That's the one I want to get to next because we're going to do what we did.
Yeah, we will. Yeah.
And it's got a little map in it too that shows where the one's right under Portland there.
All righty.
And it's not going to take us too long to go through that one.
I've seen this one, yeah. In fact, we had it on last time.
Yeah.
Go ahead, you can take care of it.
Okay, so we'll get up at the top. Fault zones in and near Washington County. 3 active local fault zones consisting of shallow crustal faults exist in proximity to Washington County. The Portland Hills Fault Zone beneath the Portland metropolitan area, the Gales Creek Fault Zone along the east flank of the Coast Range, and the Mount Angel Fault Zone in the northern Willamette Valley. These local fault zones can experience earthquakes of magnitude as high as 6.8 to 7.2. The 1993 magnitude 5.6 Scott Mills earthquake, originating from the Mount Angel Fault Zone, was one of the most damaging earthquakes in Oregon's history and is an example of a crustal earthquake. The Portland Hills Fault Zone lies just east of Washington County. The zone is comprised of 3 crustal faults that trend roughly northwest to southeast and are about 2 miles apart. The Oatfield Fault, which runs along and just west of the spine of the Portland Hills, the Portland Hills Fault, which runs directly under downtown Portland, and the East Bank Fault, which runs along the east bank of the Willamette River. According to the Oregon Department of Geology and Mineral Industries, DOGAMI, they call it for short, several lines of indirect evidence have led to the conclusion that the Portland Hills Fault Zone appears to be capable of generating a large magnitude earthquake. These faults are believed to be capable of generating an earthquake of magnitude 6.8 to 7.2 on average once every 1,000 years. In the past 150 years, the Portland metropolitan area has experienced 6 earthquakes of magnitude 5 or greater. The most recent earthquake to significantly affect our region was the March 25th, 1993 Scotts Mills earthquake, a magnitude 5.6 earthquake with an epicenter about 30 miles southeast of Washington County. Impacts from this earthquake included toppled chimneys, damages to the state capitol, school closures, and the failure of walls made of unreinforced masonry. Damages totaled $30 million. A large magnitude earthquake in the Portland Hills Fault Zone would cause strong ground shaking and damages in Washington County. According to an earthquake scenario created by DOGAMI, a 6.8 magnitude earthquake along the Portland Hills Fault would cause ground shaking intensities on the modified Mercalli scale, ranging from violent, intensity 9, in the Portland Hills to severe, intensity 8 in Beaverton and Tigard, to very strong, intensity 7 in the central areas of Washington County. So that's the USGS fault thing, where they do the computer model of it. And I think it was done in 2017. So it's like 8 years out of date. Because if you look those up, all the computer models, a lot of them were done 2017, which is also when all the quaternary fault USGS ones first came out. They're supposed to be all updated again, like right around 2025, I think. So
yeah. I was looking up the East Bank Fault, the history of that. So that's what I was trying to do.
Yeah.
So because there's several faults that go through the. See if I can.
Well, what it looks like to me, Portland Hills Fault is like in the middle of the hills, and then those other the Oatfield and the other ones are the foot of the hills, right?
Yeah,
and it doesn't say
East Bank Fault is to the east. Portland's through the middle. Then the Oatfield is toward the ocean side, and Portland's quite big for not a whole lot. I mean, it's not spread out like Los Angeles or anything.
Yeah, and they say the Portland Hills Fault runs right back to the Mount St. Helens seismic zone, so they're all
well, yeah.
connected.
If you have that on list, then I can appreciate that.
Yeah.
But
that's all the newer stuff.
Yeah, this article I got is from 2000, I believe.
Yeah.
East Bank Fault Geophysical Characteristics Investigation, Portland, Oregon. It's been kind of tough for us to find
Information on it.
Yeah. We've been to there's a LiDAR viewer open. Let me see if I can. I think I've been here before.
Now the next article I want to do has the older historical quakes in it. So the ones previous to this one talked about the most recent ones, but this other one has the ones all back to 1877 because it's going to be important when we look up the other ones. So, and I'm not going to read the whole thing of this one I put in because I only want the historical ones at the end of it because it talks about a lot of the same stuff we've already talked about already. But I just want the dates for the quakes at the bottom to set up what we normally do.
All right.
Yeah. So I'm going all the way down to like the last paragraph in this one. Portland has an earthquake history with the largest number of earthquakes recorded anywhere in Oregon on land, they should have put. Partly this is an accident of early settlement of the Portland Basin. An earthquake on October 12th, 1877 resulted in intensities as high as 7 in Portland. Lower intensity earthquakes were recorded in Portland on February 3rd, 1892. So when I saw that number, I said, well, that's interesting because 1892 was the big Laguna Salada quake down in Baja. And it also was the Vacaville Winters quakes were also in 1892. So I said, oh, well, that's fun.
That's San Francisco area.
Yeah. Yeah. And then it says, well, December 29, 1941, which I never looked up. Yeah. And December 15th, 1953, which I never looked up yet either, but that was the year after the Tehachapi quake. So that's interesting. The best studied earthquake struck on November 5th, 1962, which was 2 years out from the Chile 9.5 and 2 years before Alaska. So that's interesting. With an epicenter near Vancouver. So there must be a Vancouver, Oregon. And a magnitude of 5.2 to 5.5. This earthquake caused minor damage, including fallen chimneys and broken windows. So I got those dates and I said, well, that's exciting. I was already doing 1993 before, but I liked all these older ones because then I could look up other stuff. So I'm going to do this like in chronological order because I was interested in the 1877 one. So it was October 12th, 1877. So I looked back into the GIA thing. I was talking about this to Joe when we were on the phone before all this. And looking up what was happening back then is pretty interesting. So that's what we're going to do. So do you still have the GIA link, Joe, or do you want me
Yes,
to put it in?
I have it.
Okay. But I may as well put it in there just so that people have it if they need it. I got to get it here.
And I guess that most of those people who are on the other channels other than Twitch have only had the podcast voice, no images. So sorry about that.
No. Uh-oh.
That's all right. Well, you can get through the reading. They're tough reading. I'm just showing the articles and stuff. Yeah. Going to 1892.
No, we're going 1877 in that vicinity because we want to see what was going on after that.
1877.
And it's fun.
All right.
And,
All right. 1877, we have a Chilean quake in
Yeah.
May. We have a Peruvian quake in 78.
yeah.
And then in 78, we have a United States quake in May.
Yeah, I guess where that United States quake was. The exact same spot. We just had the Mendocino 7.
Hmm.
And if you look
Yep.
at the other ones that were happening right around then too, 1876 through 78, guess what else was going off with big quakes?
Vanuatu.
Yeah, more than one.
Let me see here.
That.
Hey,
So I
imagine
thought
that.
that was
And just south of Port Vila at the time,
Yeah.
1878. 1875 was closer to Port Vila. And 1875 was down just south of the other one. They're calling that one Loyalty Islands. But
Yeah.
I don't know about
The whole
that.
thing was going batshit crazy. So I thought that was interesting. So they're all like big ones, noticeable enough that they make this big list.
Yeah,
Does it have-
1875, 1878 had several of them.
Yeah.
And then 1898 had one as well. A 7.2. So Vanuatu, reason we bring it up is because just recently we had a 7 out in
0.3.
And
yeah,
we had
7.3 off the coast.
4 in Chile too. Remember?
This year we had a
Yeah, we just had 6.4 down there near the bottom.
Oh yeah.
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 So it's the same thing kind of now. It's
So
just not
what we're trying to conclude, extrapolate is saying when this goes off, we can see a trend that this goes off, that goes off, and that goes off all at the same time within a short period of time, geologically speaking. And we only look at the 2-year sector, 1 year before, 1 year after, to try to see if there is a flow.
Yeah, so in this case, Portland had the quake in 1877, October. And I think it was May 1878 was the 7 at Mendocino. So in that case, Portland shook right before Mendocino had the 7. Because if you look that one up in 1878, it's almost in the exact same spot, pretty much, as where we just had the 7. So I thought that was super interesting. Which I just found that by accident when I started looking into
Yeah,
that.
when we were talking about it earlier today. Yeah.
And I said, U.S. quake. What? Where? 1878. And I zoomed in on or clicked on it and it showed me, and it's the exact same spot that we just had the 7. So I thought that was freaky.
Yeah.
And they say it in stuff about it that it was a 7 to 7.2. But when I look into the records here, like North America records, they say that one was only 5.8. So I don't know what the discrepancy is. But if that's the case, if it actually was a 7 to 7.2, it's the exact same size as what we just had.
Right.
So
We say 7.4 to 7.9 Owens Valley, 1872.
Yeah.
1868 Hayward quake.
Yeah. So see, this is all in that
Hawaiian quake.
bit
Yeah.
after
Hawaiian
all
quake,
that.
1868, 1867. Kansas had a 5.1.
Yeah.
California, 1857. Fort Tejon, 7.9.
So
And that's 1857. I apologize. So I went way too far. So
Yeah,
67, 68, 71, 72. Okay, what year are we looking at? 77. Okay.
77 is
And I got
what-
crazy. I went too far back.
near at the end of the year. So that was 1877. So I thought,
Yeah, 73 was Oregon, California, Oregon border had a 7.3.
Yeah.
a 7.3. We just had that.
Yeah.
That's November 23rd. And that's November 23rd.
Yeah.
Pretty close
Well,
to the time that happened.
Yeah, if you look at a bunch of those quakes, it's always like seems to be the later
You know,
part.
later in the year. Yeah, we always say in California, we always said that winter was earthquake weather. I don't know why, but
now I never looked up the other ones because once we got into the 1900s, well then
12.5 is when the
you can
7.0 happened
with the Wikipedia.
What? Say it again, bud.
Once we get into the 1900s, you can do it with the Wikipedia one.
Yeah, it's only showing me the few that I had from 1800s.
Yeah. Look, well, the next one there is 1892, but we already talked about it.
Yeah.
So we know what was going on then because that was those other big quakes.
California had a Vacaville. Yeah, Vacaville, and that's up by Central California, I think, 6.4.
Yeah.
Also California, a couple of 6.4.
Now, the next one in the list there is December 29th, 1941. Well, I remember the Imperial Valley earthquakes were in 1940 because we talked about them before in the California.
Yeah, that's Southern Cal. Yeah.
Yeah. So Portland acted up in 1941, near the end of the year. So
December of 1940 had New Hampshire had a 5.5.
Yeah.
And a 5.3.
Yeah.
So,
opposite side.
I mean, that's 1940. So looking at 1940, also El Centro had a quake of 6.9 in 1940.
Yeah, that's the Imperial Valley one.
It's called the El Centro earthquake. Yeah.
Yeah. So now, if we look up 1941, because it was December 29th, so like end of the year, same time as now. I think we should look up 41 and see what was happening in 41 because I don't remember we ever looked up 41 before.
I think we may have touched it, but briefly. Yeah. All right. So January, Nicaragua had a 6.
Oh, that makes sense.
Peru had a 6.5. February, off the coast of Northern Cal had a 6.8.
Oh.
All right.
Sense.
Mexico, Oaxaca had a 6.6. The Dutch Indies, the Talud region, the Dutch Indies, that's Java area, right?
Yep.
Yeah, East Indies, Celeb Sea. Those were all rocking and rolling. And there's a Greece one, a 6.2. Can you believe it? God, why is Greece always in the middle of things? Mexico, Baja come up with a 6.0 in March. That's crazy. The Curil had a 6.5. Kodiak Island had a 6.5. Juji, Argentina, 6.5, 7.2. Mutualcom, Mexico had a 7.6. The Colima earthquake of 1941.
Oh, Colima's getting in on the party.
Yeah, 1941.
Well, that makes sense.
The reason why we say that makes sense because we can see the patterns persist.
Yeah.
Now we're into June.
We're doing this one live. I never looked this one up, so
right.
I'm not surprised.
Doing it live. East Indies are really going. Tabasco, Mexico, 6.2. And that's southern Mexico.
So Mexico, Central America, rocking.
Argentina 6.2, Chile 6.0.
South America, roll.
And Mexico off the coast of Chiapas had a 6. Southern Alaska had a 6.4. Now we're into August. The Rat Islands came in with a 6.8. Unimac came in with a 6.
Rat Islands is close to ADAC.
I know, Unimac. Unimac 6.8 right after that.
Yeah.
And then Argentina comes in at 6. And I think Argentina just had a 6.
Yeah.
Watch out.
Was it 6.2 or 6.1?
Yeah, something like
Recently?
that. Yeah, just the other day.
Yeah, it's all magic.
California Nevada border came in with a 5.6. I think that just happened as well.
California,
Up by Tahoe.
Nevada border. Well, this is getting more freaky.
It's getting weird. Peru 6.4, Hawaii 6.0, Alaska Peninsula 6.5. So it went from the Rat Islands all the way inland to Alaska was
That's
mid
probably what
sixes.
it's going to do now. It's just
Yeah, we're moving into
chat.
it. Then in October, off the coast of Northern Cal had a 6.4.
Yeah.
Peru had a 6. November.
So it had a 6 like
Wow.
2 months before it happened.
Uh-huh.
No, that's interesting.
And then you know what happens with the Nankai Trough, it pops with 1941. But Sandwich Islands had a 7.1, and we did have a quake in the Sandwich Islands here just the other day. And the Azores, Gibraltar, right, had an 8.0.
And 41? Wow.
Mhm.
Well, that's that
Wow.
same east-west line from Greece coming
Yes,
across.
sir. Yes, sir.
It's all magic.
And at that same time, that happened like what on the 25th, the Kyushu Nankai Trough happened on the 18th. So just a week later, the Azores popped with an 8.
Dang.
So same east-west line, right or down.
Yep. Costa Rica pops the next month in December at a 7.3 and a 6 and a 7. Well, China. I mean,
Whoa.
so coming across the Azores into Central America, because it does that drop down. It tends to go right into that Caribbean plate and push it at a southwest direction, and that's 1941. Now we get into 42, and in January of 42, Peru pops with a 6, right? And then we go to February. Honshu still with a 6.5. Still, it's quaking like crazy. Japan 6.9, 6.8 in March. It's just coming apart. In 42. Wow. Well, they should never have bombed us. They used the earthquake machine on them. So Guatemala pops with a 6.5 in April, as Japan pops with another 6.5. I mean, damn, they 41 and 42. They should have never went after us. Venezuela had a 6.0. Ecuador popped with a 7.8. See that downward from northeast down to southwest trend all the way into big quakes happened.
Coming down.
7.8 Ecuador. Colombia pops with a 5.8. 1942 June. Northern Marianas, okay, that's a 7. Mexico, Michoacan pops with a 6.8. And get this, there's another Greece, 6.2. What the heck? And Chile, Valparaiso comes in with a 7. So we went all the way down from northwest to, northeast to southwest from the Azores.
Yeah.
And
So you can see what was going on.
Uh-huh. Chile pops another with a 6.8 in July. My God. Yeah.
Okay.
August.
Now let's stop on this one and go on to the next one.
Hold on. Guatemala popped with a 7.7 and a 6.5. And get this. And Peru popped with an 8.1. All in August. And then the Fox Islands popped with a 6.9 in September. And October, Southern Cal pops with a 6.6. Mexico off the coast of Oaxaca, 6.2. Peru again, 6.8.
And
Indian Ridge.
yeah, the
Oaxaca
last
6-1.
two big Nankai trough quakes were in both 1944 and 46.
Well, you can see it starting 41.
Yeah, like
Holy
if you
smokes.
get into the 2, 3, 4 year thing, you can see how it all.
Yeah, my land. I mean, it's getting big 6s and 7s, and wow, Oaxaca 6-1. Central Mid Atlantic Ridge is 7-2. So that's kind of from that 8 from the Azores moving south. Argentina 6-5. So wow. Cook Inlet, Alaska 6-5. And Colombia 6-5 in December. So that's interesting. Not a whole lot. I mean, it moved the North American plate, and so Cook Inlet hit and Alaska hit. We had a little small one in, the Fox Islands hit with a 6.9, a 7 something probably. South America banged super hard.
So these quakes that we're starting with are all the 5s in Portland area. So this is what it has to do in order to make a 5 in Portland.
Right. Let's see. Portland's just translating that pressure north, and the whole plate moved on that 8. It banged the it banged the crap out of South America. And I'm going back up, even looking at, trying to find out. I mean, shoot, howdy. And in 42 was just horrible. And Costa Rica banged super hard. The Azores, that 8. But Japan's 8 happened in Kyushu in 1941, just a few days before the Azores. And it's like the whole entire Pacific plate bounced.
Well, we just had Kyushu quake was a 5 something.
Yeah.
Here the other day, like after we had 7.
Yeah. You called it when it happened, right when we got offline. I was like,
Magic.
dang it. So
I'm gonna be excited to look up the next one because it's December 15th, 1953.
Yeah, we'll
know what happened in 52.
I know. We'll get there. I'm still interested in seeing what led up to. So we have the a Northern Cal with a 6-4, but we just had a 7. Remember that. And Alaska, plenty of 6-5s, which Alaska's been banging off pretty good. We also had a Nevada quake, which I think if I went to the USGS, I don't know what the size was.
Yeah, it was in that. Yeah, it was in that list of the Nevada quakes that we looked up. I remember.
Yeah, 30 days.
So it must have been a 6 to make that list, although it had 5s in it too. That list we looked up.
Right here, 5.7. So Nevada border 5.6. So that trend still works.
Because we just had it.
Yeah. So the earthquake here and the earthquake here. And then we have up here, remember ADAC, that was just going off, right? So that's
we had a little swarm going.
Yep. And then right up in here, Nikolowski, this there is the Fox Islands. That was hitting. It hasn't hit up here yet in this region. So that's a missing spot so far.
It probably will.
And just watching things going on, yeah. And this is working with 5s and stuff. We can see it, but if we go any lower, there's Rat Islands at 6.8 and it's Unimac at 6.8. So that happened in August of 41.
Well, we're just doing it with the obvious quakes, right?
Right. That's because there's so many swarms of 4s and 3s and 2s. It's hard to see. We're just trying to extrapolate out of it what we're seeing and the trend. And I know there's been some quaking in Mexico. So let me look in Mexico here. This will only give me a couple of days back, 2 days, 3 days.
It's been basically 4s and 5s in Mexico right now, though, hasn't
Yeah,
it?
it's been Oaxaca and down here. Yeah,
Pacific Rise one,
right,
24.
right. And there was also a Sandwich Islands quake too, and that's in our list right here. A 5.0 and a 5.2 and a 5.3 in the last 30 days. So, and here's an interesting one of a 6.4 down in the bottom of Chile. Yeah. Right. So big stuff happening. And I don't know where that Rick James was. Yeah, today that's the Rick James way up in the north. And today was the 4.8. So there's two along the ridges today. The Mid-Atlantic was 2 days ago. And then there was a pretty good one, a 6.0, a week ago. And this was 3 days ago. So the Mid-Atlantic's really pushing right now. We have 5.5
We just need
power.
a big push out of it to get things
Right.
going again.
It started up in Iceland, and all the way down till you get into Sandwich Islands, banged with 5 pluses, low 5s, but still. And that's why we have the Mockeries today, a 5.7. So that pressure moved all the way down there too now. That's pretty interesting. But we still have another date to go on. What date are we looking at now?
The next one is December 15th, 1953. So
All right,
December again.
All right, so I'm going to look at 52.
Yeah, well, we know what happened in 52 because
I don't remember. I blank my brain out, so I go through it and like to get surprised.
Well, I know anyway.
January, Mexico, Chiapas had a 6.8. Peru had a 6.3 in January. February,
Here we go again.
here's Peru, 6.9. Nicaragua, 6. Nicaragua, 6.1 the next month. Hokkaido, 8.1. Wow. Oh, wow. 7.1, 6.3, 6.7, 6.4, 6.3. The Gulf of Cali comes in with a 6.4, and then Japan continues 6.5, 6.0, 6.9. Then Alaska does a 6.1. Then back to Japan, 6.5, 6.1. Holy
Dang.
smokes.
Wowzers.
Yeah. Whew. The Philippines comes out of 7.3 out of that, and North Korea at 6.3. Oh, wow. So April, Japan, another 6.3. Philippines, a little 6.3. Another 6.0 out of Hokkaido. Colombia had a 6.5. Chile had a 6. Hokkaido had a 6.2. It's like it's never stopping. And we're into May, a 6 for Japan.
And this is in 52, so that we're like a year.
Yeah, a year before. I know. Costa Rica, 6.4. Panama, 6.3. Oh my God, a whole slew of 6s out of Japan. Off the west coast of Hawaii, 6.0. Didn't we have this year a pretty good banger out of Hawaii, like a mid 5?
Yeah.
I want to see where.
We've done 52 before, but you'll remember when we get to it.
Yeah, okay. I'm
I
just
don't think
looking.
we did 53. But
I'm just looking to see if what we had here in this year in Hawaii. I'm sure there was I want to say it's a 5 plus.
You're gonna remember it when you get to it.
Okay. I just want to see.
Because we've already done this 52 before.
Oh, we have.
Yeah.
Yeah, there was a 6. Look at that, Hawaii, 6.0. All right, and in 52, it had a 6.0. Chile a 6. June coming into Colombia 6.1. Argentina 6.5. Then July, Chile 6.1. There's the Vanuatu and Loyalty. We already looked at those 6.5, 6.8. But Central California 7.5. Kern County. That's the Tehachapi earthquake in 1952.
We already looked it up. Well, what did we have this year? We had the
we had a Tehachapi, near 6?
Yeah. It's magic.
Yeah. Draw the
We're
line.
still not into 53 yet.
Hold on here. Draw. I just want to see what it was. Search. Yeah, right there. It was a 5.2. And then out there, you see Nevada. Nevada didn't quake that big all the time. So we have 3 or 4 indicators already this year of the same or similar events happening. Yeah.
And we're not even into 53 yet.
We're not into 53. We're August of 52. Chile had a 6.2. Central Cal, Kern had an aftershock of 5.5. Costa Rica 6.7. Hey man, Costa Rica goes crazy. Northern Cal 6.0. We already had the 7 right there, right?
Yeah, there's some weird.
There's also a 5.3.
Costa Rica and SoCal.
And Argentina 6.1. Yeah, there's a connection between these. Northern Cal 6. October. Freaking, my God, Japan just never stopping. Haiti had a 6.2. All right. That's on the Caribbean plate.
Yeah, so you're getting close to the Texas liniment and all that again.
Yeah, Mexico Gulf had a 6.3. Nicaragua had a 6.3. Central Cal had a 6.2. So again, another aftershock after that Tehachapi quake. Yeah. Kodiak Island comes in at 6.8. That's where I'm thinking something like that's going to happen. But also Chile. Alaska Islands, a 6.5. There's Greece, 6.5. God bless America.
Yeah, the Greeks are always up to no good.
Right. A couple more 6s come in right after that in Crete. I guess something happened in Kamchatka that year. I must have missed. I wasn't looking for it. IB Clemmer. IB Clemmer joined. Hey, is he back? He got bounced. Yes, I don't know how you got bounced, bud.
I don't know.
Yeah.
Well, he never got an emergency alert that his internet was being.
All right, so we're in the 52. We want to go to 53.
Yeah, because that's when the quake was.
All right.
December 15th, 53.
All right, so we're doing the whole year before, and then we're doing the year of. Yeah. My God, there's a bunch of.
For some reason, Portland loves December quakes.
Yeah. Near Islands in Alaska had a 7. Canada, Yukon Territory, 6.3. Haiti, 6.1. Haiti hasn't popped yet, but there has been some quakes over there.
We had Cuba this year, remember?
Yeah.
Pretty close. Not
Greece, Daikanese had a 6.2. Northern Marianas, but okay, blah, blah, blah. Argentina, 6.2. I'm not trying to say you're no important, but I'm within our context here. Ecuador, 6.1, 6.2. Brazil, interesting, 6.5. And then Peru with a 6.1.
So South America's busy.
Yeah. In May, Chile pots with a 7.5. Concepcion. Yeah. Whoa. The DR pops with a 6.6. I know we had a DR quake. There's the Cuba 6.8. See, yeah. I don't know. There's a Colombia quake of 5.0 too. Boy, watch out. The DR pots with a 6.6. So I guess in context, what we're saying is I'm only looking primarily on the eastern side of the Pacific Ocean, and then I can't not exclude talking about Japan, and because it's just going ape. And then there's this kind of a outlier, so to speak, and that's called Greece. It's a very odd event when things are happening in the west of North America, eastern side of the Pacific Plate. Greece is always sticking its nose in there, greasing the wheel, I guess. So Kodiak pops with a 6.5, and in July, oh my gosh, there's Vanuatu, Japan, Northern Marianas again. El Salvador pots with a 6, Chile pots with a 6, August Chile parts with a 6.2, and good old Greece 6.3, 6.5, 6.8, 6.2, 6.0, just goes ape turd all over the place. And in September, Chile pots with a 6.3. Yeah. There's Cyprus with a 6.3. Mexico, Gulf of California has a 6.8. Uh-oh.
It's magic.
October, Mexico, Gulf of California, 6.2. There's Greece at 6.2. Dang it. There's Bolivia. We don't normally hear about Bolivia too much.
Yeah, Bolivia is usually deep quakes.
Yeah, 271 depth, and it's a 6.8. November. That's near the armpit of South America, right, by the way. If not in it. Yeah. Guatemala, 6.8 off the coast.
Yeah, it's all making sense.
And we're in December. Off the coast of Guerrero, 6.9. Chile pots with a 7.2. Antofagasta. Peru, 7.3. Chile, 6.3. Not to be outdone. And that's 53.
Yeah. And I know in 54 was a big Nevada quake because we looked that up in the other show. And 54 was also the last big one on the San Jacinto.
Yeah, Guerrero did a 6. Chiapas did a 6. Nico 6.8. Couple of 6.8s in Nicker. And Michoacan had a 6.
So to me, it all makes sense how it's working.
Guerrero 6.
Even
6.
without looking up the actual year.
Yeah, Southern Cal had a 6.4 in 54.
Yeah, that's the last San Jacinto 6, I think, was in 54.
Okay. Hawaii pop with 6.0 and a 6.5. And Mexico Chiapas 6. Adrian Islands a 6.6. Mexico,
And
Gulf of Cali.
Nevada had a big quake in 54 too.
At 6.6 and 7.2 Gulf of Cali in 1954. Then there's Greece. 6.7.
He's still going.
Nico 6. Gulf of Cali 6.4 again. Oaxaca 6.3, 6.0. And then in June, Ecuador 6.3. That's the Galapagos Islands, by the way.
Yeah.
Peru 6.5, 6.6. And in July, Nevada 6.8. Okay, it's not as large as that. It's what, a point lower? Yeah, point lower. So what we're seeing as a point lower in most of this stuff, even what's happening today, the Haiti, you can say, is the Cuba quake. That's a 6.8. That's relatively close. The 7.0 is not a 7.3 off the coast of California. Off the coast of Oregon was a 6. And then we still have the 6.4 up in BC in the last month. But in addition to that, we have a bunch of quakes in Baja California, a swarm of them in the last 30 days. And of course, Guatemala had the 6.4. and 6.1 and a 6.2 right after the 6.8 in Cuba. So it all started out here in the Azores. It went all the way down, banged here, went to South America, wiped it out, went to Colombia and Ecuador, Peru, and down to Chile. And it came right back up. And then when it did, it banged out here. And of course, I didn't tell you, but Kamchatka was blowing up, and so was of Japan. All stemmed from a little old 8 sitting out here in the Azores.
Yep.
That's pretty crazy, dude.
Well, and
Yep.
it's not very often that you get a big 8 coming out of the Azores either,
No,
is it?
no.
No, only when it's like the same years as Lisbon,
Yeah.
because you'll find it's all the
17.
same thing.
Yeah.
Is that like once every 500-year deal or once every
No, it
1,000
goes
year deal?
off way more often than that.
Uh-huh.
Which is why they just did the tsunami drill for North America, which was like a year or two. I think it was a year or two.
Yeah, the East
ago.
Coast. Yeah.
Yeah,
they
they
2
were
years ago.
simulating
Yeah.
8.6 off of Lisbon.
Yeah.
in the
Because
Azores.
Lisbon had a near 8, and then 5 years later had another near 8.
Yeah.
And then it's been quiet ever since. Because Lisbon, which is up in here, got pummeled. It destroyed it. Changed the way Portugal runs things.
Yeah, because there was another big one off Lisbon, but farther out the same year that there was the big quake down near the Bahamas. Because I think they're all connected. I think it was like 1813 or something. Made a tsunami in the Chesapeake Bay. They figured out those were all the same years. There was another offshore Lisbon out farther than what it was in 1755. And then there was a quake off Bermuda, Bahamas that same year that they think was a 7 plus. In 1813, I think it is, or something around that time. So this would be like almost 80 years after 1755. But they had to figure this out based upon like where it was and all that, based upon the stuff that recorded in Bermuda, Bahamas, and the people in Azores that recorded it out farther. Because it didn't make, I don't think, a big tsunami that went into Lisbon like what it did in 1755. So, but that's an aside anyway. I don't want to get into
Well,
that.
in 1954, Baja California was popping pretty hard.
Yeah.
At 6.1, 6.4s, and had a bunch of other ones in there. And Nevada had, get this, not 1, but not 2, but 3. In
There was a bunch of them all.
in June. Yeah, in June, I want to make sure it's not any before it.
But
Southern
California, it makes sense with all the other stuff that was happening.
Right. If you look at the whole year here, Mexico, Gulf of Cali was popping pretty hard with the 7.2s and 6s, a bunch of slew of 6s. In the midst of that, Southern California hit with a 6.4 in 1954. Right? Hawaii popped really hard with a couple of 6s. And then we have to go to the Gulf, another 6.4. And then when we get to, I think it's in July? Yeah, July. Nevada popped with a 6.8, right? A very, very large quake. Then it comes back with a 6.2. And then in August, it comes back with a 6.6. And then Baja California continues. And then in November, Baja California continues. And in December, Nevada popped with a 7.3 and a 6.9.
And there's a new
And Northern
Tumblr.
Cal popped with a 6.5.
Yeah, there's a new Tumblr article that's talking about the latest Nevada quake being somehow connected to Mendocino.
I agree with it.
Yeah. So that's what they're talking about because Wilsey mentioned that in his hour-long
Oh, he did?
today. Yeah, because he had read the Tumblr article or whatever. Because people were asking all sorts of stuff in chat today when he had questions. Like they were asking about Cascadia and all sorts of stuff.
Yeah, I saw that he had an art. I for plagiarism rights, I don't.
Yeah, and he's been doing like reports on all the earthquakes.
Sure, he has been. Yeah,
Yeah.
you got to stay relevant. Yeah,
Yeah.
because Iceland's slowing.
Yeah.
Interesting evening, and I don't know if
we still got to do 62 and 1993. Yeah,
I think we're I don't know how much time we're into it here. We're an hour and 40 in already. I think we got lost with doing that, and we got out of Oregon. To bring us back to Oregon.
Well, we're still looking up the quakes that are in Oregon.
Well, I got you. I got you. And what brought them up, and
because I can give you the simplified version for 62.
Yeah, all right. Do it. Just do it.
So the other Portland quake was November 5th, 1962. So not quite December, but pretty close.
Right.
Well, 62 was halfway between the 1960 Chile quake, 9.5, and the 9.1 Alaska quake.
Yeah.
In 64. So that's pretty straightforward. Now, I don't know what was happening in 61 or 62. I haven't looked it up yet. I don't remember. But the simplified version of 93, which was the last time there was a fiver near Portland. Well, they call it the Scott Mills quake in 1993.
Right.
But we know from our previous studies, 92 was Landers and all the crazy earthquakes off of Oregon.
Mm-hmm. Also, Northern Cal, right in off the Mendocino.
Yeah, and then 94 was Northridge. So when all that stuff was happening in Washington in 93, it was in between all the Landers thing and then Northridge. So I thought that was interesting. And also when I looked up 93 in Oregon, it wasn't just by Portland that was shaken. It was Klamath.
Southern.
Also had a 5.9 and a 6 that same year.
Yeah. Well, you'll find it interesting in 1962. Yeah. The Greece hit again with a 6. But also the Mid-Atlantic popped pretty hard. Panama popped real hard, 6.5. And then Mid-Atlantic Ridge had a 7.3.
Yeah.
In was that March? I'm kind of scanning through it. My gosh, Guerrero had a 7, 6.8. Oh my gosh.
Same thing again.
Yeah, I mean it's so repetitive. Panama 7.2 again. Colombia 6.5.
Yeah, but it's all random though.
Greece, and then there's Utah. Like I said, every time the Mid-Atlantic Ridge pops, you got to look out through not just the coast of North America, but you got to look into the center part of the United States. Utah had a 5.9 in 1962.
Yeah, well, that makes sense.
Yeah. So it's like then the Fox Islands went ape shit, It's 6.2, 6.4, 6.5, 6.5.
Like it's getting so bad now, I don't even have to look them up. Because
Yeah.
I can guess.
I mean,
that's
it's the same kind of what do you call it? The same, like that movie, the same subjects or whatever,
Yeah.
suspects, same suspects or something. And it's that there's 5 or 6, 10 events that are going to happen in a 2-year period. But the trick is to see, a couple events happen in these areas and going, okay, where do the other ones happen? Okay, these are the likely suspects. Okay, and what's the power that's coming through? Okay, and if the power's not real big, like this year has been really quiet. Of course, we've had two 7s in the last, week,
Yeah.
but
so it hasn't been as crazy as like these other years that we're looking
no, this is a very
Right,
low
right.
low year, and generally speaking, on a solar maximum, that's what happens.
at. And
So-
so when Portland gets a quake, it has to be batshit crazy everywhere to match with the Antifa.
Yeah.
people.
Yeah, and it really has to be banging down in Baja California. It seems that Baja California is the runway for everything. Now, mind you, there are interior quakes when the mid-Atlantic hits, and you'll always see when the mid-Atlantic hits on the other side of Alaska, you'll see that translate, because it is the same plate, by the way. America's just in Canada's just put in the middle with Mexico. And we've already seen, evidence of 5, 5, 5, 5 all the way down to mid-Atlantic. What's that going to translate into? Well, we already have a 7 at Mendocino. Oregon's quiet as a mouse. Nevada's popped. But offshore Oregon had a 5, back in
Had a
October.
6.
Yeah. And a 6 back in October, the end of October. And a few other ones, 5.2, 5.1,
Bumping North
5.6.
America east, so it's adjusting on the opposite side.
Mhm. And then we
Smashing.
have up in BC, 6.4 and a few others. Southern Cal in the last couple of months, a 5.2 on one side, and in Los Angeles, I don't remember what it was. I think it was in a 4 range.
4.7, I think.
Yeah, I'm not sure what it was, but I know it was further than 30 days.
And we had the Barstow one way back at the.
Yeah, remember the Barstow one out in I don't know how long ago that was. Shoot,
It was way
that had
back.
to be about 4 months, 5 months ago, right? Yeah, the
That was kind of
Mojave.
midsummer.
Yeah, search catalog.
And then
just-
we had the Bakersfield one.
that's what I was referring to. Is right here 01.
Because I think
There's some-
the Barstow one, I think, was before that. I remember right.
Mm,
So Barstow happened before.
yeah, Barstow was lower than a 5 because I did a search on the 5s. I mean, yeah, 5. So I'm going to do a 4.5. All right, search. Yeah, it's in there now. All right. Yeah, Barstow was a 4.9. Whatever, dude.
Yeah, I think it was like 5 or 5.1 originally.
And then Oklahoma had a 5.1, Texas had a 5.1 and a 5.1 and a 4.5 and a 4.7. Stanley, Idaho had that 4.9.
Yeah.
We have up off the
4.9.
BC, if Port McNeil and 6.4 in Vancouver, and then we had the 6.0 and the 5 off Oregon, and the 7.0 was there. Nevada popped with a 5.7. you know. Interesting. You can see Walker Lane, and then it never popped in San Francisco. It just never did. There was a couple of small quakes, but nothing of any significance. And I thought that was kind of weird because it's like it went around it. So, but what we've seen is up here in the 7, just by looking at the latest quakes, 30 days, you'll see the trend. You know, it's moving inward. The quake was happened out here, and it's actually moved kind of south and inland. And we see a couple little pushes. Like today, there's even another one. And they got these funky names, you wouldn't even know it. But you see a series of quakes go right through Lake Alamo and then move right into Reno to the swarm that's happening right now out in Nevada. And then another one in Nevada. And then a bigger one down in southern Nevada. At that same time, a little bit through Mammoth and through Ridgecrest, that line from Coso and, you know, popping right over through Ridgecrest. And you can see it continue right through Barstow all the way back to the San Andreas. And that's
And
pretty
remember,
interesting.
we had the Death Valley swarm too.
Yep. Death Valley out here.
And with that swarm just across the Nevada border in those northwest to southeast faults that come down.
Yep.
Going towards Vegas.
Yep. It's right in just north of a little town called Indian Springs, just north of the Spectre Range.
Yeah, Indian Springs Valley Fault.
Yeah, Rockville and Jackass Flats and Palmagosa Desert, basically. So that stuff's happening, man. Take a quick look over here.
Looking at the news on my phone.
Yeah, you are. All right. Well, I guess pretty interesting evening. Probably not for those over on the other channels because all they get to do is hear the podcast. There's no video to it. I might edit and put the video and stuff at a later date. But you have anything else you want to close with, Luke or Canuck?
I got a couple quick questions for Canuck.
Yeah.
When out in the West Coast, off the in the Pacific Ocean, when did they start putting the seismograms out there to pick up like these quakes? 100 miles off of Brandon, Oregon, or out into the oceans.
Yeah, well, they did it on land before they started putting it on the islands.
Right.
Like for example, I looked up Galapagos, and they didn't actually put the good seismos out there that picked up stuff until the U.S. rebuilt the airport because they had like a Air Force base or whatever on Galapagos after World War II, and I forget what year it was, like 50s or 60s, I can't remember. So they rebuilt the airport and did it all over. Well, that's when they added the good seismos.
Okay.
To it that were like, so it depends on which island you're looking at. And like Iceland was the same thing. They had seismos there, but they weren't the really good ones. So like the 60s, so that they were better at locating where the quakes were. Even though they have records going back, seismo stuff like maybe to 1900, they weren't super detailed. They just knew it was out there somewhere. They didn't have like an exact location where the quake was, which they were able to do when they added more seismos. Same in the Arctic in Canada.
Okay.
Just only at like a few of the northern cities or towns, and then they added more. So they could figure out when a quake happened, they could better find out where it was and what the magnitude was. So
Yep.
it kind of depends. Like the first seismo in California, I think was like 18. I think it was like mid 1800s, and it was at where Berkeley is, because they had one there. I think for the 1868 Hayward Fault quake, they had a seismo at Berkeley, but it was sometime previous to that. They might have had them there when for the 1857 quake too. So it might have been
Okay.
like it's like late 1840s, early 1850s.
Yeah,
So it
yeah.
kind of depends on where you're looking
Well-
it up, but you can find all that information. It's just a matter of figuring out when it was.
Right. I guess my second question is, we are constantly we're putting these patterns together.
Yeah.
And kind of on our current trend right now, this might be a slightly off topic, but do you see a pattern where we've went like right now 3.5 years without having an 8 or something bigger? Is that kind of something you see in a repeating pattern too as you
Well,
look back?
sometimes you go a long time between them, but usually, like it did, like what it did in 21, where you had 3 8s, right? So then
Right.
it's almost like it's taking a break because it's normal to get 1 8 a year. That's the normal thing for 8s, and then 9s is spread out over longer periods of time. But usually with an 8, you get at least one every year. So if you don't get it for whatever, you get a whole bunch in 1 year, then it's like it almost takes a break for a little bit until it starts going back on its normal schedule
Yep.
again. And the 7s vary all over the place, like depending on the year. Like if you looked up every year, you'll see that the 7s sometimes are way lower, sometimes they're way higher. But I think you
Yep.
have to have like a bunch of 7s to get like an 8 or a 9 by the stuff I've studied so far. But that would be mainly like 1900 stuff.
Yeah, but like I was asking though, you see in patterns going back through time, where like in 21 we had 3 8s, and it might go 3, 4, 5, 6 years without having another one.
Yeah.
Okay. I'm good
like
then.
I've seen probably 3 years at the most that I can think of right off the top of my head. But
Well, right now we're at 3.5 almost.
yeah, because normal is an 8 every year.
Right.
In the 1900s and up to now. So since they've been keeping track of them, like it's harder to find out the farther you go back. It's easier in certain places because they have better records. But so like when I'm doing all this stuff, once I get back below 1900, I have to look at that gigantic global historical earthquake archives thing that goes back to the year 1000.
Okay.
Yeah. So I still can find information individually. Like if I did a search for earthquakes in 1838, well, then I get a bunch come up, right? Individually. Yep. So I read about each one. But if I want to coordinate them one with the other, then I have to go to like that historical database. Because I believe it works how it's always worked. So you still should be able to prove this in the past as much as you are in the present or in the future. And that's really what.
I think you're. Go ahead. I think you picked up on something there, Luke. It hasn't happened in the 21st century yet. We're already 2024. Having 3 years of 0 8s. The most it's been is 1, and I went back from as far as I can go back to 2020 or 2000 actually, and I don't know about the 1990s. Let me look at the 1990s. But it hasn't happened 3 years in a row.
Right. And, like Canuck said, you average 1 8 per year. You know, and in
yeah,
21,
it's generally that, yes.
and in 21 we had 3 of them. You know,
Well, that's based upon what they know about since 1900, because it'll say that in things.
Right.
Like if
Right.
you ask those things a question, it'll say, well, based upon the data we have from 1900, we should
Yeah.
have an 8 per year.
In 2004 we had 2. In 2006 we had 6. I mean 2. In 2007 we had 4.
Yeah.
In the following 2 years we had 1. 2008 and 8 9. All right. So, you know, and if I go to 2010, well, I'm sorry, I should have gone a little bit further. 2020, sorry. And in 2012 we had 2. 2013 we had 2. And then now if I go back to 24, in 2021 we had 3. It's unusual to have 2 years in a row without an 8. It's
and we're
highly
on
unusual
3
to
plus.
have 3 years without an 8.
And yeah, and we're 3 plus.
No, yeah, we're 3. Yeah. 21 we had 3 8s. And
Yes.
if I go back to when was the
Last one
4?
was that sandwich, I think.
Yeah, in 2007 we had 4 8s. 8 plus, sorry, it could be. Yeah. 8 8, right? And but you know, they don't always call them 8s. We've learned that.
Well,
Well, you
let
could
me
get
ask you this.
7.9, right? And it might have
Well-
originally came in as an 8, but then they downgraded it.
Right.
So
That's the question I wanted to ask you, Canuck. That 7.8 that happened in Turkey, I think it was the beginning of 23.
yeah, there's actually
Um,
3 quakes: 7.8, 7.6, and then a 6 point whatever. It made a triangle.
But that
That's another
7
story
point,
for another day.
that 7.8, it now, if I remember right, originally came in at an 8.1 and then was
Yeah,
immediately downgraded to 7.9 and then a 7.8.
But then the problem was you got the other 7 right close to it a few hours later,
Yep.
right after. So
I think it was like 4 hours later, 3 hours later, something like that.
yeah, and then, but when I read about that historical quake that was in the same place in the 1100s, it was the same thing, right in that same spot. It did 3 quakes. And I don't think they've even clued into it, because you got to look at the 1100 stuff to see that it did the same thing back then, and then it all came right down, right through Syria and Lebanon, right to like Damascus and the Bekaa Valley, and then it went right into the Dead Sea. So I think that's what it's going to do again, if they compare to what happened in the 1100s through the 1200s there, because it's following the exact same pattern right now. So like the same area that everybody's all going batshit crazy fighting over now should be within the next 100 years time period. There's going to be multiple 7-size quakes all coming right down there through, right down the Dead Sea Fault Zone, right through Israel, which I find interesting. Because guess what was going on in the 1100s? That was when the Crusaders were there. Because the Crusaders got taken out at their underground fortress they had at Marash, it was called back then, which now it's called Catamaran with Marash on the end, because they changed the name of it after World War I or World War II. They added the Turkish hero, it means hero in Turkish, onto the Marash. So where that quake just happened in 2023 is the exact same place that happened in 11, whatever it was, the start of the 1100s. And it took out all the Crusaders that were at the fortress. And then this all coincides with the same time that the Crusaders all left the Middle East and went to Oak Island. Because that's the whole Oak Island.
Oak Island. Give me a break, Oak Island. God bless America.
And
Jeez.
now the latest stuff is the Vikings were the ones that knew about Oak Island. That's how they got there. because the Vikings were allied with the Crusaders when they came back from the Middle East. So that's how it all works. And now they figured it all out because of all the artifacts they found on Oak Island.
Well,
Because
this,
the
yeah,
last
thi-
2 years they found Viking artifacts, and they went
yeah,
to
right. You're right. I don't believe any of that crap.
they went to
Still no
Iceland.
treasure
man.
yet, though.
They
They
threw
went
it
to
down there.
Iceland and found all the same things are in Iceland at Reykjavik. And at the museum there, the
All right.
pieces of the boat they found in Smith's Cove are an exact duplicate of the Iceland Viking boats. And then this year, since it started this year, they went to Newfoundland and found where the settlement was there, the first Viking settlement in Newfoundland. They found that the stuff they've dug up there is the exact same stuff that they found on Oak Island.
And that's like saying that the dang Egyptians were in the Grand Canyon, man. Come on, you swallowing all that stuff.
So the Vikings were all the way down to Nova Scotia partying with the local Indians.
I think they were in North America for sure. I think they were in North America. Oh, get this. Here are the sevens that happened this year. There have been 10 of them. Right? Here we are, the 12-18. Right?
Yep.
And I'll do it by the date. Japan popped with a 7.5 to start the year. Then China had a 7 in January 22. Then we had to wait till April 2nd for a Taiwan 7.4. And then a couple months later, in June 28, Peru. Then on July 11 was the Philippines. July 19 was Chile. A 7.1 and a 7.4.
How big were them quakes, Joe?
7.1 and a 7.4. Then Japan again, August 8th was a 7.1. And then August 17th was a Kamchatka 7. Then the California was a 7, and then Vanuatu was a 7.3. So
We're way low for the year.
yeah, it was 10. And on and we are low for, I mean, 2020 had 9, 19 had 9, 2017 had 6. But it had an 8.
7?
Mm-hmm. What's really interesting is anything, at 6.0 and to 6.9, only 88. And I think it really has a lot to do with the way they calling quakes nowadays. So they got this new system they've been putting through. And periodically you'll even see quakes get downgraded in the historical record because of the way
we were talking about that the other night, but
yeah.
And
So-
when I did the top 3 quakes of every year, no matter what size they were, so the top 3 biggest ones, it always made a triangle, and it was either gigantic or right close together. So I thought that.
Right. Just the patterns that persist. I mean, we naturally look for patterns. That's how we recognize things. We're, as human beings, we're in, it's like a core part of us looking for patterns. Some of us excel at it more than others, but some of us are just attuned to it and they're able to see it more than others. But the 6s is substantially lower. On average, at the low for the last 10 years, the low was 104. We're at 88.
so we got 2 weeks to go in the year, and we're way short.
Way short, yeah.
Yeah, unless it's just going to decide in 2025 to catch up on one.
And get this, that lasts all the way past 2004. Because I just did a search back there. The average between 2013 and 2004 is the lowest is 125. And that's on 13. And if I go back
Right.
another 10 years, the lowest is 118. So the last 24 years, counting, or 25 years, counting 20 or 1999, between 6 and 6.9, we have 20 of them less than anywhere else at any other time. The sevens in 1999 had 18 with no eights, but there was always an 8. The missing eights are 99 and 2002, like I said before. 2016, 2020, 2022, 23, and 24. So it's only been what, 1, 2, 3, 4, 5.
Unless we get like an
So-
eye out of the corner, but there should be a lead up to it though.
7
Like
times in the
whenever
last 24 years we've not had an
Boy.
8.
See what was leading up to them.
So
But we've never had a period
you
this
one
long where
correct
without
correct,
it.
correct. It's 1/3 in the last 24 years has not had an 8. So it's a 2 to 3, right? Chance for an 8 to happen. And still we have 2 weeks. Does it look like anything's building up for that out there? It could be, but it'd be in the Orient or in the
Well, man, high trough lights going off in September or in December.
yeah. I was
So, yeah.
thinking
Well, and also
PNG
if you
or
compare-
somewhere, in the islands in what do you call it, the maritime continent. I was thinking somewhere out there, but PNG and Vanuatu's 7.3 the other day, today or yesterday or whatever it was. That could be a precursor to something else.
They had damage there.
Yeah, they had some damage. Now Vanuatu is most of the time that I'm looking up these things, I was seeing Vanuatu all happen all the time. PNG and Vanuatu and Santa Cruz Islands and the like. So it is pretty crazy to see some of these things, reoccur.
right?
But,
Yep, exactly.
we have other kinds of earthquakes in this world that are happening right now, such as the war in Ukraine, the threat of nuclear war from Russia, who's feeling the pinch incredibly. And this jackass president of ours right now, he wants to go to freaking war because he's going to die anyway. He don't care. He'd rather I want to be known. Well, you're not going to be known because the world ain't going to remember you because nobody will be around.
Yeah, it's kind of hard to remember people when you're in a nuclear winter.
I'd take his. The only reason you can't take his ass out because she's more dumb than he is.
Yeah, you would not want her, that crazy lady in the White House for
No.
a month.
Word salad. Unfortunately, we're stuck. Now, I don't know. I don't think he's capable of being president, and yet they still keep him there. I don't know what's going on.
He's just the bobblehead.
He's a bobblehead. She's a drunk. And the next guy in line, he's a warmonger because he's a rhino.
Yep.
So,
Well, you know what the old saying is, wars generate money.
but this kind of war won't. We've pushed Putin to the edge. It's not, he's coming out saying, hey, look, guys, we might just retaliatory hit you. Now he can go into Syria, take his bombers, bomb the shit out of our guys in Syria. He knows where they're at. Say, hey,
Well, I'm sure he
retaliatory. Get the hell out of Ukraine.
Eye for an eye.
You know, this push, and I'm watching. I know Canucks watching it too. This push is pretty damn serious. Russia's getting their ass kicked. There's a meat grinder, and they now have 300,000 troops in Ukraine, the most they've ever had, and they're pushing to get to Dnipro. That's the point, the pincer. They want to get to the river. And I don't think Ukraine has 300,000 troops. I think they're barely having 50. But because of our weapons that we've sold them and give them
300,000 drones.
Yeah. And you know, they're hitting like that general that just got hit. I don't think that was I think that was a CIA hit, but to hide something, you know, what's really going on in this war, you know, to the International Monetary Fund and the insurance and all that, and how come that we're over there and the world is over there is because they were dividing up Ukraine, and Russia got in the middle of it. Says, nah, you're not going to do it. Not here.
Yeah,
so we're just going to take this port.
The Houthis again right now.
Yeah. Well, the Houthis are just, you know,
yeah, the British
whoever's leading them is just, they're insane. You know, and also the Syrian leader, the Syrian interim leader, who's he's a terrorist, and he's just declaring Sharia law. But he says, but don't do it right now. Don't do it right now. Wait till we get all the power together. So what he's trying to do is he's trying to consolidate all the power.
Israel's basically to the outskirts of Damascus now, and they just took over the 2 hydro dams in southern Syria. So now they control all the power in the water that runs into Jordan too. So Israel's in control of that, all that stuff now.
Well,
so, but Turkey's the latest is mounting all their troops on the border. They're saying they're going in to get rid.
They're going to try and but the Kurds, and that's where we have troops.
Yeah.
And Turkey started this war. Israel cut the legs out of Iran, and Turkey jumped in and did this.
So there's a lot going on still.
And Russia told Dragonhead to get out. And he wanted to stay there and fight, but he didn't have any troops.
Okay.
Hell, all their planes were crap. Now they're all gone.
The troops they really had that was their support was Hezbollah and the.
Yeah, well,
it's from
Hezbollah just got the shit kicked out of them. Yeah, and Iran.
So they're all gone now. They're totally blocked off. They can't.
I think Israel's bombing, 125 sites every single day. It's insane what they're doing. They're just beating the shit out of them. Why? Because they know they're terrorists.
And supposedly there's 1,500 Hezbollah missing, according to the southern Lebanon stuff. So they assume they were all blown up because they can't find them.
Oh.
So there's 1,500 they can't find.
I agree. One of the my dad loves studying it, but I cannot stand it. And that is the war inside the States when we did our Civil War. I just don't. I mean, I love Americans, and why they're shooting each other and killing each other, I hate it. And then to have these wackadoodles trying to press us into doing that now. And yet some people are okay with it. because
But
they don't understand what
a
really
war
war is
today-
about, man.
A war today, in our current situation, would be totally different than the Civil War, because
Yeah.
back then it was North versus South. Now today, it
It's
would
everybody
almost
for
be
themselves,
neighbor
yeah.
versus neighbor. You know,
Mm-hmm.
Well, now it's actually technology versus non-technology, or 40 years behind. It's really it's
Right.
because that's what's actually happened to the Russians and the North Koreans. Like what they're
And
getting taken out by is not like an old-fashioned bayonet fight.
yeah. Well, the Russians are using technology from the '90s, where we're 30 to
The
40 years ahead of
1980s,
them.
yeah. 1980s. They
Well,
have
it's-
they have a few stuff. They have a few
it's-
stuff. So don't
It's the
say.
same thing like Syria versus Israel, or Hezbollah versus Israel, or Hamas versus Israel. It's the same thing, right? Their technology's 40 years behind. Well, really, Iran, same thing.
Well, and the technology that they're using today, we won't see till 2050, 2060.
Who?
The U.S., the technology that the U.S. military is using today will not be available for sale or to the general public, till 30 years from now.
'Cause
We're not the
the
only ones with it, though.
the
That's the problem.
F-24 is supposed to have cloaking technology, so you can't see it, and it's going to fire lasers and phasers by it. You read all kinds of stuff.
Yeah. Just like they're aliens, right? Yeah. Okay.
Well, everything
Well, you
that's
know,
in sci-fi we're going to have.
There is a
like,
technology of hiding things, and the Japanese, the Chinese, and we have it already. It's in sheets. I've seen it, and
yeah, but
it
like I'm
plays-
saying, even GPS
yeah,
was developed
Well,
back
it's
in
just
the 80s.
whatever's on the outside of the plane.
I agree with you that the technology used to go about every 18 months. Now technology is popping off freaking every 4 to 6 months and going up to a new level. It's so astronomical. Now AI is exponentially going to go batshit crazy. So trying to hold this monster back, forget about it. They've known about this. They've always had connection, I believe, to everything and everything. Every electronics already has a back door. They know what you're saying and what you're not saying. They can interpret. And on top of that, they can make video of you doing something that you didn't do. And it's so good video that you cannot say, I didn't do that. That's me, but I didn't do that. They can make your voice, they can make your face, your actions. Some of this stuff is just astronomically wild.
Insane.
And they can do it live on TV, make somebody walk by somebody and you erase them on the screen in live TV. I've seen it happen. It's like, what the hell? So their technology is so far superior to ours. However, it's all out there. Just like what we're doing, trying to put things together. I think they can do it inside of an afternoon with an AI, if they haven't done it already. The stuff that we're just stumbling upon and the patterns that we're watching and seeing, they can do it from 7s, 6s, 5s, 4s, 3s, and have it done in an afternoon and say, yep, and
Well,
improve it
and
all.
if you read about satellite stuff, they have data that they haven't even deciphered yet, because they have to give it to like a private company that
Deciphers it. Yep.
Whatever aspect of whatever it is they're trying to figure out. Like they have all this whole bunch of data, but they don't know so much. They don't know what to do with it all. So they haven't even figured out how this.
Once it all gets digitized, things will radically change. Just like it's supposed to be, where there's going to be a massive holograms.
And a bunch of the solar stuff.
People are going to believe these holograms. How many times you've seen on YouTube and
where the
Facebook
data center
that
is,
there's
it's flooded or something.
these things walking in the clouds and stuff? You ever seen that stuff? That stuff's just hokey as hokey.
Because wherever it downloads the data to for all the solar stuff had a flooding issue or
Yeah.
something. That's supposedly why we're missing all this.
Yeah, that's up
Latest.
there in up there in USC. Yeah.
Yeah.
We are just plebes. Yep. Pleaded fifth, man. I don't nothing. Anyway.
Well, I greatly appreciate it, guys.
Yeah.
Thank you, too. Thank you so much for participating and being a part of this, guys. I know the new year things are going to change just a little bit, but we'll still have some fun and some other stuff happening that's in the pipeline. It just takes time to do it, and I appreciate you all.
Yeah.
Have
So
a
I
good
guess
evening.
What are they going to do? Head to Washington next time?
Yeah, Washington. Yeah, Southern Washington on Saturday. Love y'all. Take care. Have a good evening.
All
Good night.
right. Good night.